Welcome in a new video, and in this video we are going to understand about the types of operating system. In a previous video we understand about what is an operating system and what is its goal, what is it basically services provided by an operating system. In this video we are understanding about the types of an operating system. Okay, so let's recap what we understand in a previous video, that operating the important point, which is that operating system basically execute a program. Operating system is what basically do, it execute the program. Okay, and this is a very important feature of our operating system as well, because if you are not executing a program, if a user want to do some task and that task is not execute, then what's the mean of that system? Okay, so operating system basically help us to execute that program. So in a type of an operating system, there are numerous operating system which basically transfer process to CPU. Okay, so it basically take process from a main memory and give that process to the CPU. Okay, so now let's understand that how they do and basically what basically happens in the different types of operating system. Okay, so first of all, the very basic one, which is uniprogramming operating system, which is uniprogramming operating system. Okay, by its name it is clear that it says uniprogramming operating system. It means we have CPU, and CPU want to execute. CPU will able to execute only one program, and let's say this is our main memory, RAM. Operating system is definitely there in a main memory. Have only one process in a main memory, let's say it's P1. Okay, we have only one program in a main memory. So this is what a uniprogramming operating system is. Means operating system in a main memory, there is only one program, and only one program is basically executed by the CPU. So operating system is what it basically do, it give P1 to, it basically transfer P1 from a main memory to CPU, and CPU execute this program. If there is any input output operation or any kind of an operation which CPU has to wait for that, then CPU are not going to take any other program, because in a RAM there is only one program. That's why it's called uniprogramming operating system. We have only one program to execute. Okay, so I hope it is clear to that what is a uniprogramming operating system. So an operating system which allow only one process in a main memory at a time is called uniprogramming operating system. What does mean? OS will allow only one program to execute at a time, one program in a main memory and one program in a main memory. Here you can see that it's RAM, and in a RAM there is operating system and only one program. Operating system and only one program. That's why it's called uniprogramming operating system. Okay, so OS will allow only one program in main memory, or you can say main memory, or you can say RAM. Okay, main memory, or you can say RAM. Okay, so this is what a uniprogramming operating system. I hope it is clear to you that what is a meaning of an uniprogramming operating system. If there is any kind of an input output operation or any kind of operation which CPU has to wait, then CPU will wait till the completion of that different thing like input output operation, and then when P1 this program will get an input, then in again resume. Okay, so see, in uniprogramming operating system, what's the drawback? Drawback is simple, like a CPU will not use very efficiently. Okay, CPU will basically wait till the completion of the P1 program, and then P1 fully execute, then it leaves CPU. When P1 full execute, then another process P2 come in a main memory, and then P2 goes till if P2 want to perform P2 want to take an input from a system or from a scanner, then it firstly take that input, analyze that input, and whatever needed is taken by the P1, and then it again execute by the CPU. So till that time CPU has to wait. So this is what a drawback of a unit programming operating system means. CPU has to wait, CPU is not used very efficiently. Okay, so this is a very simple unit programming operating system. Now after that unit programming operating system, we have called multi-programming operating system. What it is called? Multi-programming operating system. Okay, so remember this thing, it's a program. Okay, here you can see the unit programming, multi-programming. So okay, first of all understand the difference between the program and process, because so many times you see these things. Program is a different thing, process is a different thing. Okay, so program is what? Program is basically a set of instructions. Means whatever you write a code, that's a program. The source code is basically a program. Okay, the set of instruction to perform any task is a program. But when process is what? Process is when program plus the execution time. This is what a process is. Program plus execution time. What is program? Set of instructions. So process basically contain program. Yes, process basically contain program plus the execution time. What is an execution time? Means till the starting point to the end point. Okay, what's the time taken to perform this task is basically a execution time. We will see this thing when we solve a CPU scheduling questions, that how basically CPU is scheduled for the different processes. Then we understand the execution time in detail. Till now you can understand like that the starting point and to the end point. Till means if program is basically go to the CPU, that's the initial point, initial time, and then program fully execute, that's the final time. So the difference between the final and initial is basically the execution time. Okay, so the program plus the execution time is what? Process. Program plus the execution time is a process. Okay, so now let's understand this operating system, which is a multi-programming operating system. So here you can okay, so in the unit programming we have only one program, and by its name it is clear that it's a multi-programming operating system. It means CPU can only execute one program, but in a main memory RAM we have more than one program. So operating system is definitely there, and after operating system we have so many program, P1, P2, okay, P3, or whatever the size of that main memory. So that's basically the program placed in this RAM. Okay, operating system is responsible to take so many program at a time in this main memory. Okay, so here you can see that we have so many processes. Now what operating system do? Operating system transfer one process to CPU, and remember this thing, CPU can able to execute only one process at a time. If one process is when one process leave the CPU, then only the another process can able to acquire CPU. This is what important thing is, CPU can only execute one process at a time. Okay, so you can write it like note that CPU can only execute one process at a time. Okay, so this is a very important thing. Okay, so now P1 is goes to the CPU. Now P1 execute. Now here is the same case. When P1 want to do some another operations, so what basically happen now is when P1 want to do another operation, like let's say it's want to take an input from a system, then basically it take time. So that time the CPU is basically become empty. CPU become empty because now P1 want to take an input. So what P1 do? P1 leave this CPU and collect that input, and then again come to execute. But in multi-programming, remember this thing, when P1 is doing input operation, CPU is empty. That empty time or what operating system do is operating system take another process and give that process to CPU So here you can see that how CPU is efficiently used. CPU is not become empty now. If it want to do input operation, the process P1 program can do that thing, and P2 program is basically get the CPU. Now P2 is there as well. Remember this thing, CPU can only execute one program. Okay, one program is doing input operation, another is executing. Okay, so now P2 is also want to take an input, and these things done in a very millisecond. You cannot even notice these things. Okay, so these things done in a very fast. Okay, so now P2 is also want to do an input, and P1 is also doing an input operation. Okay, so now CPU become empty. If CPU become empty, what operating system do? Operating system take another process and give that process to CPU Now P3 is also having CPU, but remember what I said, that CPU can only execute one process at a time. So P1 is executing and P3 is executing, and now P1 is completing their input operation. Then also P1 is not getting the CPU till the P3 will basically fully execute or doing any other operation. Okay, when CPU become empty, then only P1 will able to again get the CPU. So this is what a multi-programming operating system is. Okay, so I hope it's understandable that how multi-programming basically work. Operating system provide process to CPU. If CPU processes CPU program, whatever the program basically operating system send to the CPU, if that program is doing input output operation, then another program get the CPU. This is what multi-programming operating system functionality. Okay, and so you can write it like this, that operating system which allow multiple programming in a main memory, that's basically a multi-programming operating system. Okay, so remember this thing, in a main memory, what process is basically occur is basically done by an operating system. Operating system is the one who collect the process and write that process in a main memory or in a RAM. Okay, and the process cannot go directly to the CPU. Okay, there is a thing which is called PCB. We will see this thing in upcoming videos. Till now you can see that, understand like that, process goes to the CPU, and if they do some operation, then another process get the CPU. Simple. Okay, so what is a multi-programming operating system? Multi-programming operating system which allows multiple programs to be in main memory. Then basically that operating system is called multi-programming operating system. And there is one more thing which is called degree of multi-programming, which is means number of processes in an operating system. Here you can see that we have only 3 processes, 1, 2, 3. So the degree of multi-programming in this case is 3. Means what is the degree of multi-programming? The number of processes in a main memory is called degree of multi-programming. So degree of multi-programming, so I write it like DMP. Okay, so what is it? Number of program in RAM or in a main memory is called DMP, degree of multi-programming. What is DMP? Degree of multi-programming. So I hope it is clear to you that what is a degree of multi-programming as well. Okay, now we are moving to a different thing which is called now the multi-programming operating system is of 2 types. We understand this thing as well, that types of multi-programming MP operating system. MP is basically what? Multi-programming. Okay, so we have two types. First one is called non-preemptive, and the second one is called preemptive. We see this thing in detail in an upcoming videos, but for a basic in an overview, in a summarized way, what is these two things? Non-preemptive means when a process run on a CPU and it leaves CPU only when the process is execute completely. Non-preemptive means program get the CPU, now it become process. Okay, so process, remember this thing, what is a process and what is a program. Okay, when the P1 is in RAM, in a main memory, it's a program, but when it goes to the CPU it become process. Okay, so now P1 is become process when it is in a CPU. Okay, so process, in non-preemptive case, process can only leave CPU. This is what CPU, and P1 is there in a CPU. Process P1 can leave the CPU when the P1 is execute fully. This is what a meaning of a non-preemptive thing. Operating system when send this process to the CPU, now operating system cannot remove this thing. If it is not operating system not removing this thing, this process, then it is called non-preemptive multi-programming operating system. Okay, so I hope it is clear to you that what is a non-preemptive thing means. Process when execute fully, then only P1 can leave the CPU. But what is a preemptive? Preemptive is basically just opposite of this. Process can forcefully leave the CPU, means P1 is doing their operation, but there is P2 process which urgently need CPU. So the priority of P2 is higher than the priority of P1. Okay, P1 can wait for their completion of a process. P1 can wait for the completion, full completion of that full execution, but P2 come and said that I need CPU because I am doing the most and I am doing the important thing. Okay, so the priority of P2 is greater than priority of P1. So now operating system, what operating system do? Operating system forcefully dispatch the P1 from a CPU. So now P1 is basically leave CPU and P2 get CPU. Although P1 is not completed right now, but operating system forcefully leave the P1 from CPU and give CPU to the process to second program. Okay, so this is what a preemptive multi-programming operating system. Okay, so these are the two types. We will see this thing in detail when we are solving some questions. Okay, this is a basic overview. Now after that we have another operating system which is called multi-processing operating system. What is called? Multi-processing operating system. Multi-processing operating system. What is a multi-processing operating system? It is basically used by a computer with multiple CPUs. Here you can see that it is said multi-processing operating system. So program become process when program get a CPU. So in this case it says multi-processing, means there are so many processes there are so many processes. So multi-processing operating system is basically, in this case there are more than one CPU and operating system provide process to the different CPU for another process to the different CPU. Okay, so it is used by a computer with multiple CPUs or having multiple CPUs, Okay, so this is what a multi-processing operating system is, and it is also of two types. So what are its type is tightly coupled, or you can say it's shared memory as well, shared memory. And what happened in this case, in tightly coupled multi-programming operating system, in this case we have memory. Okay, so we are writing like this. Okay, so in this case what happened, we have a main memory. Okay, this is what RAM, we have main memory, and we have CPUs. Remember this thing, we have multiple CPUs. CPU 1, CPU 2, CPU 3. But remember this thing, memory is only one. Now there are programs P1, P2, P3. Okay, so what operating system do? Operating system give the program to the different CPU to execute. Now here you can see that every program is executing. So what does that mean? That means this is a very fast computer. This is a very fast computer. Okay, so multi-processing operating system, so many CPUs doing so many programs, so definitely it's faster than the what we study these two, multi-programming or uni-programming. Okay, so this is what multi-processing operating system and a shared memory. You can say shared memory multi-processing operating system or a tightly coupled multi-processing operating system. Remember this thing, we have only one memory. In that memory all the programs were there. Now the second type of multi-processing operating system is loosely coupled. Loosely coupled. Now a loosely coupled, or you can say it like distributed system. Okay, so now what happened in loosely coupled or a distributed operating system? In this case there are so many CPUs. Definitely in this case also we have so many CPUs like CPU 1, CPU 2, CPU 3. But in this case we have main memory as well, like say main memory 1, main memory 2, main memory 3. Okay, so we have different main memory, so definitely we have different operating system, because we know that operating system is in a main memory, is in a RAM. So one operating system is there, another operating system is there, another operating system is there. So we have 3 main memory, so we need 3 operating system. Now these all things are interconnected. These things are interconnected, means all these main memories are connected, and it basically know that which program is executing to which CPU. So let's say that P3 program is basically done by CPU 2, and this one is done by CPU 3, and one main memory 1 programs are done by the CPU 1. So here you can see that so many memories, so many operating system, means so many processes can easily execute on this thing. So this is what loosely coupled or you can say distributed system. Okay, so I hope it is understand that what is the multi-processing operating system and it is type. Okay, now we are moving towards the next operating system, which is called multitasking operating system. Now the another type of operating system is called multitasking operating system. Now what is a multitasking operating system? Multitasking operating system is basically an multitasking means simply doing so many processes. It means doing so many processes, like let's take a CPU queue, and now let's say that P1 is doing their P1 is completing their the P1 program is executing, P2 program is executing, P3 program is executing, then again P1 is not fully executed, so again it get a CPU, P1 is executing, P2 is executing, P3 is executing, means it multitask these processes. Means one process is running, is switch to another process, switch to another process, is switch to another process, so that every process is easily execute. And this is what our operating system is as well, do these things. Means if you are running so many things in your system, so and we know that CPU can only handle one process at a time, but you are using YouTube, you are listening music as well, you are opening any other application as well, then you are using 3 programs at a time, then how all the 3 programs are easily executed? So there is a concept which is called context switching. What it do, it basically switch this process, means these things were done in a very millisecond of time, you even not able to notice these things. But what CPU do, P1 is there executing a little bit, leave the CPU, P2 is executing a little bit, leave the CPU, P3 is executing a little bit, leave the CPU, then P1 again, P2 again, P3 again, P1 again, P2 again, P3 again. So this loop is running till when you are not closing that particular process, and And if your system is not capable to do that, when you see that if you are using so many programs, so many processes are running in your system, then your system is basically hanging. Okay, it's not able to work properly. So when you are using so many processes, so this thing is also done. Okay, so what a multitasking operating system is, it tasks different processes at a time. So how you can do, and remember this thing, it's an preemptive multi-programming operating system type, or you can say extensive of preemptive multi-programming operating system. So what we understand about a multi-programming operating system, so many processes, so many CPUs, so it can do, but in this case there are only one CPU but so many programs easily execute by simply doing a small execution. Okay, so you can say that extension of preemptive multi-programming operating system. Okay, so this is what a multitasking operating system is, in which processes are executed in a round robin manner. So processes are executed in a round robin manner. Processes are executing in a round robin manner. Round robin means for a particular period of time, for one particular process is executing. Let's say that round robin is 2. So P1 can only execute 2 milliseconds at 2 milliseconds, P2 execute 2 milliseconds, P3 execute 2 milliseconds, then again P1 get the CPU and it only run 2 milliseconds. So there is a numerical as well on a round robin. We will see this thing when we are solving the numerical. But now what is a round robin manner? We have some particular limit of time and that process can able to execute that particular limit only. Okay, and when it reach, it leave the CPU and another process get the CPU. So this is what a multitasking operating system is. So I hope it is clear to you that what is a multitasking operating system. Okay, so this is what multitasking operating system is, and this is all about in this video. There are so many operating system as well, like multi-user operating system, where so many users will be able to execute at a time, because now you are using your system, you can only able to type one thing, you can able to do only one thing at a time. But when there are so many users were there, means you want to play a game, so many joystick is having in a hand of more than one person, so two person can easily coordinate with each other and easily play the game. So this is what multi-users. You are not one, you are now two user is using the system, and that system was managed by the multi-user operating system. Okay, so this is also an operating system, multi-user operating system. What basically does, we have so many user, let's say user 1, user 2, you are playing a game. So you are playing a game and we have the terminals T1, let's say T2. Terminal is what? Terminal is basically like keyboard, a mouse, joystick, whatever. With the help of, you are using the system, with the help of something you are using that system, that something is called terminal, and like keyboard, mouse, and whatever the input output operation is basically going on. And these terminals are connected to the multi-user operating system. Okay, and that multi-user operating system is coordinated with the hardware, and whatever the user do is reflected on your screen. Okay, so I hope it is clear to you that what is a multi-user operating system as well. And there is a one more operating system which is called real-time operating system. Real-time operating system. This is also very important in the case when you need to execute a program in a very fast way. You need some data in a very fast way. For example, that P1 is CPU 1, P1 is process is running, and in CPU 2, P2 process is running, and P2 process generates some output, and P1 need that real-time output. Then in this case the real-time operating system is basically used, and these things are used in a rocket type of thing. Means at that particular time we have to dispatch the engine from a rocket so that it can easily leave the orbit of an earth. Okay, let's say an example as well, like we have the rocket is running, and rocket have to run with a speed more than 11 km per hour to leave the earth, so these thing, real time data is basically, when you deal with a real time data, you have to use a real time operating system. Okay, you get this data, and after leaving an operating system, what should be the speed, so that thing is also done by a real time operating system. Engine is attached with this rocket. After some time, after when it reaches certain level, it need to dispatch so that it can easily leave the orbit. So these things is basically done by the real time operating system, where you have to deal with a real time things, you use real time operating system, and this is a very important operating system in a space organization. Okay, so this is what it is. Now we have some, okay, so we understand about the two more operating system, which is an embedded operating system. What does this mean? It means that when operating system is embedded on any system which allow to attach with the other devices is called embedded operating system. Like for example, you know that okay, so let's take an example of AC. Now AC, okay, so when the room temperature is at certain level, when room temperature reach certain level, the AC value, the AC degree is basically increasing so that it can balance these things, because room temperature is very accurate, very normal, where it's good to live in the room. So what AC do, AC shift that temperature to AC simply match that temperature with the room temperature. Okay, so this thing is done by, now you can say example of a washing machine as well. The latest washing machine, what it do, it see that okay, number of times is they are at a certain number of time the round is taken place, so now we have to stop. How did this stop? This is stop because in the washing machine there is an operating system, and an operating system is embedded. Which deal with these things. Okay, so this is what an embedded operating system means. Any device, if there is an operating system on that, this is called embedded operating system. And the last is called handheld operating system. Handheld operating system means you are using your phone. Okay, so you are using a phone, it's the operating system in your phone is a handheld operating system. Means what do you understand by this? Anything, any devices where you can hold on your hand is called handheld operating system, like your phone. Okay, and whatever the devices you can hold on your hand and move from one place to another is basically done by the handheld operating system. So these are the basic, these are the important operating system that we have to know about. Okay, so this is all about that. Now in next videos we are understand about the system calls, how basically operating system get the thing, how operating system know that okay, the user want to do this thing. Okay, how the switches of a program is done. So we will see this thing in our next videos. So thank you for watching this video, like the video and subscribe my channel.